Part C for question number 1 asks, is the rate at which the vehicles arrive at the toll plaza at 6 a.m. or t equals 1 increasing or decreasing? Give a reason for your answer. First of all, we're looking at the rate at which it's increasing or decreasing, or we're essentially looking for the change of rate, which means we're looking for, since A is our rate function, we're looking for A prime. So that's the first thing I'm going to do. I'm going to take my A function and I'm going to differentiate it. So differentiating this, I get A prime of t is equal to, I'm going to differentiate the square root. So this becomes sine to the power of negative 1/2. Just going to clean this up a bit. So I'm applying the chain rule here. So negative 1/2 times, then I need to differentiate the sine. So cosine of 0.62 t, and then I need to apply the chain rule again, so times 0.62. So there's my derivative, okay? So I can clean that up a little bit, but really I'm just trying to find the derivative value at t equals 1. So I get 225, and I'm going to end up with, and maybe I'll write this as a fraction. Okay, in the numerator of my fraction, I'm going to end up with 0.62 cosine of t equals 1, which is 0.62. In the denominator, I'm going to end up with the square root of sine of 0.62. Okay, when I plug in t equals 1, and that's going to be my expression. Okay, so I need to then plug this into my graphing calculator. I'm going to end up with 225 times 0.62 cosine of 0.62. And that's going to be divided by the square root of sine of 0.62. And so I end up with A prime is 148.947, and that's going to be the cars per hour, okay? So since that is positive, the rate of change is increasing at that point. So since the rate of change, so we're going to say the rate of change is increasing. Part D. A line forms when A of t is greater than 400. So 400 represents the maximum rate capacity of the toll plaza, because as the number of cars come quicker than 400 cars per hour, we're going to start accumulating. So the number of vehicles in a line for time t for A is greater than t is greater than A and less than 4 is given by n of t from A to t, A of x minus 400, where A is the time at which the line begins to form. So first of all, we need to figure out when A happens. When does our A of x pass 400? Okay, so what I've done is I've graphed A of x minus 400, and that's going to tell me when A of x is equal to 400, and I get 1.469 hours. And we also need to know time t, where it's going to continue accumulating, or where we have A is above 400, so we have too many cars coming through, and it's going to start backing up. It's going to be backing up from 1.469 hours to the other point is going to be 3.598 hours. And after that time, our A is going to be less than 400. So we're going to be able to uh, process all those cars through that toll plaza, and we're going to start, the lineups are going to diminish from there. So it says, to the nearest whole number, find the greatest number of vehicles in a line at toll plaza in time intervals A to 4, and justify your answer. The justification is going to be, we know that when A of X, and I'm going to write this down, so when A of X minus 400 is greater than 0, we have cars lining up. Okay, then we have cars backing up. Okay, so if that's the case, then we know that this area above the curve represents the total number of cars that we have backed up. And that would then represents the maximum number of cars, because after that, we know that we're going to start getting rid of some of those cars that are backed up in line. So this area represents the maximum number of cars that are lined up on the toll plaza. So we can justify this with A of X minus 400 is greater than 0. So then at between T equals 1.469 hours and T equals 3.598 hours, we know that we are getting the most number of cars backing up. And when we integrate that, so if I show the integral of that, I've taken that same function, I've integrated it, and I've integrated it from those two bounds of 1.469 and 3.598. And the area that we get is 72 or 71.25 cars. Okay, so the nearest whole number, the greatest number of cars is so the nearest whole number is going to be equal to 71 cars.